All right, we've studied synthetic division, and now we're going to use synthetic division in a form of what we call synthetic substitution, employing the remainder theorem. And what the remainder theorem actually tells us, if I'm trying to find a specific value of f in a function equation, in this case we're trying to find f of 3, I can use synthetic division and divide it into this function equation, and whatever the remainder may be, that would equal what f of 3 would be. In other words, if I substituted in 3 for x into that function and solved it. So let's work this by example. We're going to synthetically divide this by 3. I've got 3x cubed minus 6x squared plus x minus 11. All of my variables are going down, the exponents are going down in descending order. They're all accounted for, so I don't have to use the placeholders. So I got 3, negative 6, 1, negative 11, writing down all the coefficients and the constant. Let's bring the 3 down, and 3 times 3 is 9. Negative 6 times 9 is 3. 3 times 3 is 9 again. 1 plus 9 is 10. 3 times 10 is 30. And negative 11 plus 30 is positive 19. And that's my remainder. And that would be the value of f of 3 into this equation. So let's see. Well, we probably got time to prove that. Let's substitute in 3 for x into this function and solve it. So we'd have 3 times 3 cubed, substituting 3 for x. Let's see, 3 cubed is 27. Negative 6 times 3 squared, which is 9, plus 3, substituting in 3 for x, minus 11. So 3 times 27 is 81. Negative 6 times 9 is 54, plus 3, minus 11. Let's go over here to the calculator. Let's run this. So 81 minus 54. Well, that's 27 plus 3. That's 30 minus 11. And shazam, f of 3 is 19. But we can synthetically substitute and find the same answer. The remainder theorem. Employing the remainder theorem. If I synthetically divide by a specific value of x into a function equation, whatever that remainder is, that is going to equal f of 3 into that function. Shall we do one more? Of course. All right, here we're asked to find f of 1. When we got our function g of x equals 4x to the 5th minus 2x cubed plus x squared minus 1. I got to be careful. What am I missing? I'm missing an x to the 4th, and I'm missing a single x. So I'm going to have to use some placeholders. Let's get set up. I'm going to put negative 1 in the box. I'm beginning to write my coefficients. I got 4x to the 5th. I have 0x to the 4th. I have 2x cubed, I have 1x squared, I have 0x to the 1st, and then negative 1. Let's bring down the 4. Negative 1 times 4, of course, is negative 4. 0 negative 4 is negative 4. Negative 1 times negative 4 is positive 4. 2 plus 4 is 6. Negative 1 times 6 is negative 6. 1 negative 6 is negative 5. Negative 1 times negative 5 is 5. Two negatives multiplied together. 0 plus 5 is 5. Negative 1 times positive 5 is negative 5. And negative 1, negative 5 is negative 6. That's my remainder. And that is using the remainder theorem. That is the same as, that's a way of finding f of 1 into that function equation. How about that?